Now we are told that a rotating shaft carries four masses, which are 1, 2, 3, and 4, and are radially attached to the shaft. The mass centers are 30 mm, 38 mm, 40 mm, and 35 mm respectively from the axis of rotation of the shaft. The masses 1, 3, and 4 are 7.5, 5, and 4 kg respectively. The axial distance between the planes 1 and 2 is 400 mm, and between the planes 2 and 3 is 500 mm. The masses 1 and 3 are right angles to each other. The question says find for complete balance angles between planes 1 and 2. It should be between planes 1 and 4. Find the angles between planes 1 and 4. Find the axial distance between 3 and 4, and then find the magnitude of M2. So to save our time, the table is drawn already. We have the first column containing the masses of containing the masses. This is the first mass. The second mass, M2, is unknown. The third mass, and then the fourth mass. And then these are their radius respectively. We have 30, 38, 40, and then 35. And then here we have the centrifugal force over omega, that equals kg mm. The unit here is kg mm, that is mass in kg times radius in millimeter. So 7.5 times 30 we give 225. M2 times 38 we give 38 M2. 5 times 40 200. 4 times 35 400. So after this we'll now move to the space diagram. So the space diagram. Now from the question, we're told that M1 and M3 are at right angles to each other. So this M1, this M3, so this angle 90. Okay, so it means we do not know, though we know the mass of, we do not know the mass of M2, we also do not know its angle of inclination. Same thing with theta 4. We know the mass of theta 4. We know the mass M4, but we do not know the angle of inclination of M4. So we call it theta 4. So we do not know theta 4. We also do not know theta 2. So we'll now move to the plane position diagram. Plane position diagram. So we're told that we have 4 planes. Okay, so the distance between plane 1 and 2 is 400 mm. The distance between planes 2 and 3 is 500 mm. While the distance between 3 and 4, we have x mm. So this is x mm because from the question we are not given the distance, but from the question we are already given this distance 400 and we're also given the distance 500. So we use x to represent this because we do not know it. That's what we are to look for. Also, from here we can obviously see that we do not know the mass M2, and then we do not know the direction theta 2. So most likely we could consider using first polygon to find the value of M2. But if we take a close look at mass M4, which is known, we also do not know the direction of inclination of M4. If you check the space diagram, we don't know theta 4. It means since we have more than 2 unknowns, we have 3 unknowns here. Since we have more than 2 unknowns, it means we cannot use the first polygon directly to solve it. So it means we have to move forward to use the couple polygon. Okay, so now for us to use the couple polygon, we need to get this. We need to get our reference plane. So this is our reference plane in millimeter. It is also in millimeter. So we need to get a reference plane from the plane position diagram. So from the plane position diagram, okay, I've redrawn it here. This is our plane position diagram, and this is the space diagram. For the plane position diagram, we can choose any of these as reference, but it's always advisable to pick the reference in such a way that the unknowns will be eliminated. If we pick M1, if we pick plane 1 as the reference, it means the unknown M2, the unknown in plane 2 will still be transferred to the couple polygon. The same thing, the unknown in M3 in plane 4 will still be transferred to the couple side of the polygon. It's better we choose plane 2. So once you choose plane 2, it means this unknown will be eliminated entirely, and once it is eliminated, then there will be minimal number of unknown for us to find at the couple polygon. So now choosing plane 2 as a reference, it means here plane 2 we are going to have 0. So backward of plane 2 we have 1, and that means plane 1 here is going to be minus 400. So from plane, this place at 0, going front is going to be plus 500. That's why here is 500. So from this place at 0 again to this to the front is going to be 500 plus x, and it means we have 500 plus x here. So what we need to do is multiply L by this value here. So 225 multiplied by minus 400, we have minus 90,000. 38m to multiply by 0, we have 0. So it means the unknown here has been cancelled out. 200 multiplied by 500, we have 100,000. 140 multiplied by 500 plus x, we have 140 into bracket 500. This is 500, not 6, into 500 plus 6. So with this, we'll be able to get our couple polygon. So we only need to choose an appropriate scale. Okay, so for the highest value here now is we have 100,000. So you can assume this to be equal to 10 centimeter. So if this is equal to 10 centimeter, that means 1 centimeter is going to give us 10,000 kilogram millimeter square. Okay, so let me take it to the drawing sheet. Alright, so from drawing sheet, so since we have 10,000 as 1 centimeter, minus 90,000 is minus 9 centimeter, that's minus 90. The 100,000 is 10 centimeter. So we can now plot this on the couple poly. You can use this. So we can use it to plot the couple polygon. So now first we have our horizontal line. We have an horizontal line, and that horizontal line, that's going to be for the plane A, for the first plane, and that first plane is minus 9. So we have 0. That's going to be minus 9. And since it is minus 9, that means it is going backwards. So it means we have 0 here, we have A here, and this minus 9 centimeter. So the next one we're told is at an angle of 90 degrees. So and that's plane 3. You can see it from the space diagram. Plane 1 and plane 3 are at right angles to each other. So we now have the next one is plane 3, which is at 90 degrees to plane 1, and the magnitude is 10. The magnitude is 10. So this is a 0A. You can call this point C. This is 10 centimeter. This is the direction of the arrow. So the closing side is going to be the unknown. Is through the closing side we are going to get the unknown that we are looking for. So once we measure it, so we get 13.4. So it means the distance OC is 13.4. So OC here is 13.4 centimeters. So this implies 140 into 500 plus x will be equal to OC multiplied by scale. So now this is equals to 13.4 multiplied by the given scale is 10,000. So multiply by 10,000. So from here we only need to make x the surface of the formula. Eventually our x is going to give us 457 mm. So this has been known already. So x is 457 mm. So we can also get the angle of inclination of this side. So it means we need to know what angle this is. So it means we need to draw another horizontal line here so that we can place our protractor there. So now this is the horizontal line. Then you place your protractor. So 90 with 90 here, 0 with the horizontal, 90 with the vertical line, 0 with the horizontal line, 180 with the, so whether we get an more accurate answer. So this place is going to measure That's around 42 degrees. So now 42 plus 270. Okay, 42 plus 270, and that's going to give you 312. So that means theta 4 is 312. So now we have been able to get theta 4, which is 312, and that answers Roman numeral 1, which is the angle between planes 1 and planes 4. We've also gotten x, which is the axial distance between 3 and 4, and that answers Roman numeral 2. So Roman numeral 3, we are expected to find the magnitude of mass M2. So for us to get the magnitude of mass M2, we need to draw our first polygon. So now, in drawing the first polygon, we need to choose between this scale. We need to choose a scale for the first polygon. We have 225, we have 200, we have 140. Okay? So we can choose any convenient scale. For instance, we can equate 200 to 5 centimeters. So if 200 is 5 centimeters, so that means 1 centimeter we make what? 200 divided by 5, and that's 40. That will be 40 kilogram millimeter. So therefore we also have 22.5 equals to 5.625 centimeter. We have 200 equals 5 centimeter. We have 140 equals 3.5 centimeter. So we have used the scale of 1 centimeter equals 40. So now all we need to do is to plot the polygon. So we measure, we first draw our horizontal line, and then we take the distance 5.625. So this 5.6, so that will be somewhere here. So this 5.625, and then we can label it this point O, this point A, this is the direction. So now the next is to draw a line which is perpendicular to it, and that line perpendicular to it, of course, you know, that's for plane 3. Because of course from the plane diagram, 3 and 1 are perpendicular to each other. And now what is that distance? What is the distance of plane 3? The distance of plane 3 should be around, that should be 5 centimeter. That should be 5 centimeter from the table. That's 5 centimeter because it's 200 there. So we measure 5 centimeter here. Okay. So now from this point, this is going to be point C. From this point, we are now going to take the next, which is for plane 4, and then you can see plane 4 is at an angle of 42 degrees to the vertical, because look at this. These are this is a couple polygon. So and it's still going to go. We are still going to use the same direction that we used here. That's the same direction we are going to use here, which is 42. So it means this place is going to be 42 degrees. So we take our protractor and measure 42. But first, we have to take our horizontal line here so that we'll be able to use our protractor very well. Okay. So now that I have done the horizontal line, we place this 90. So now we can place this protractor and then measure 312 degrees. So it means that will be 42 degrees from this place. That will be 42 degrees. That will be 42 degrees from this place. That's 270, 280, 290, 300, and then 310, and then 312. And then from here, we can draw this line here. So now the magnitude of that line is actually 5 centimeter. Then we measure 5 centimeter. So we can call this point D. So now from point D to the starting point. From point D to the starting point. That will be the closing line. And we can use short. And use short dash line there. Okay, so now Okay, CD is meant to be 3.5, not 5. So you measure 3.5 here. You measure 3.5. Then from 3.5, you prolong your line to point O using hidden lines to the starting point. So this is wrong, so you erase this one. So you now take this distance, this point D. So the distance OD should be around 8.3. So you can make it around 8.35. Okay, so you can take note of this arrow, then this, then it comes like this, then it comes, like this. Okay, so now we are trying to get the mass M2. That means 38 M2 is going to be OD multiplied by scale, and that is OD multiplied by the scale is 40. Okay, and what is OD? OD is 8.35 and multiply by 40. So from here we can make M2 the choice of the formula. So M2 becomes 8.35 times 40 divided by 38. And that should be approximately 9 kilograms. So with this, we've known the mass of M2. So we can also know the direction of theta 2 by measuring this angle. So now we have to draw a line horizontally to this, and then this angle is actually going to give us theta 2. So now we have a horizontal line through point D, a vertical line through the same point D. So I'll get an accurate measurement of this angle. So from here to here is 17. Here to here is 17 degrees. So it means the total angle here, theta 2 is going to be 180 plus 17, and that is 197 degree. So with that, we've gotten the solutions to the questions.